Hey everybody, this is Mr. Piercy, and this is going to be your first lesson, your introduction into high school geometry. A lot of times when students come to my class for the first time, high school geometry, I like to ask, well, what do you think high school geometry is? And by and large, a lot of kids always are going to say shapes and stuff, or some, derivation of that statement. And that's true, but only a small part of it is true. Students come into high school geometry thinking about it from their prior experiences of looking at shapes and figuring out maybe what's perimeter, area, or even volume. Okay, and we will be doing a lot of that at some point, but not for quite a while. That's stuff that we usually get more towards the end of the year. In high school geometry, what we really start focusing on is how does geometry even work? What are the basics, the building blocks, the foundations that made geometry what it is? So all of the things that you have already kind of talked about in geometry are really it's like the what you see on an iceberg. The stuff above the surface of the water is what you've already been playing with, and everything below the water, where a majority of the iceberg would lay, is what we're really going to be covering in this course for high school geometry. Now, just a little bit of background. There's lots of different types of geometry. The type of geometry that we know already, the ones that you've been studying in your other math classes for years now, is a branch of geometry called Euclidean geometry, and it's called that because a guy named Euclid literally wrote the book called Elements. That was the name of his book that we've been using for thousands and thousands of years. There's other types of geometry that we may have time to get into at some point. Some of them are known as taxicab geometry, spherical geometry, and hyperbolic geometry. But if we have time in our curriculum, we'll get to it. But for the time being, generally speaking, anytime we're referring to anything in geometry, we're understanding that it is Euclidean geometry that we're working with. Now here is our first vocabulary term that we really kind of need to know, a postulate, otherwise known as an axiom. It's a synonym for the same thing. Postulate or an axiom is a statement that you can accept to be true. Now, why is this important? Well, again, we're getting down to the very basics, the building blocks of geometry. And Euclid, when he was doing all of his stuff way back in the day, he developed 5 postulates, 5 statements that people could accept to be true, that everything that we know in geometry is based on. So there's a hierarchy for logic in geometry, and the foundation of that logic is a postulate. From there, from postulates, we go to theorems, which is a statement that is true, but you have to explain why it's true. And we go on from there, but we'll get into that a little bit later. So you will be seeing a lot of postulates in geometry, and so let's go ahead and look here at our points, lines, and planes. These are what are known as undefined terms in Euclidean geometry. It's not so much that we can't really explain what they are, but they're very difficult to say. They're very difficult to describe what they are without actually using the word point, line, or plane in its own definition, and that's really why we call them undefined. And these are the only undefined terms that we will see in high school geometry. Everything else will have some kind of a defined nature to it based on the way mathematics does it. So here, this is what a point is. A point just shows you where something is. It doesn't have any size, it doesn't take up any space, it's 0 dimensions. The way that we generally represent it is with a dot and a single capital letter. Now, what I want you to do here, there's a question at the bottom that says, what is a real world of an example of a point? So pause the video whenever you need to and come up with an example of that and share it with your classmates in the comment section, see what you come up with. Okay, there's a whole lot of different ways that we could do this. I'll give you an example, my own, so don't use this one, but I would say a star in the sky. That could be representing a real-world example of a point. So the next undefined term is a line. It is it's a line. It goes between 2 points. The characteristics of it is that it can't curve. It has to be straight. The way that we name a line, I want to look at this part right here, because it's a little hard to see, there's a symbol. It's a straight bar on top with arrows on either end of it that we say AB like that. The arrows at the top indicate that it's continuous. By its nature, in theory, a line will extend in opposite directions forever. This is our first object or idea that we have in geometry that is going to have a dimension. Lines are one-dimensional because they move in one direction. Now, if you notice, we can call this line AB, or we can call it line BA. It doesn't matter it doesn't matter the order of the points, as long as we have any 2 points on the line to name it. And you can also see here there's a script letter L. It's kind of an italicized letter L. You could also call it just line L. So it would be a real-world example of a line. Well, a pencil, maybe. So again, what I want you to do is to pause the video and think about, well, what would be a real-world example of a line, and share that information in the comments as well. So let's take a look at our last undefined term, which is a plane. Now, a plane is a flat surface, and the way it is formed is by looking at any 3 points that are not on the same line. And I really want you to highlight that in your notes. At least 3 points not on the same line. That's really, really important because what we're going to be doing is some of the things that we're going to be looking at in geometry is we need to know, well, what are the characteristics of that thing? And we're going to be identifying objects, in this case a plane, based on those characteristics and not necessarily what we see. Okay, so keep in mind, a plane will always exist between any 3 points that are not on the same line that we see, whether it's drawn for us that way or not. The way that we name a plane is just, we can pick a single kind of capital letter, so I can call that plane P, like you see right here. But I could also call it plane ABC. I don't have to put the letters in that order. As long as I have those 3 letters, I can name it. So I could call it plane CAB if I wanted to. The order in which we name the points doesn't matter, but typically a lot of times you will see people write them in alphabetical order. So I'm writing this on my smartboard in my room, which is representing a flat surface. So that is my real-world example of a plane, my smartboard. So again, I would like you to come up with some kind of example of a plane. Pause the video and think about it if you need to. And when you're ready, let's move on. So here we're going to take a look and see, can we identify some things? What are ways that we could name line QT? Well, line QT is kind of that vertical line that's going through the plane that's kind of been defined for us. I don't know if that's kind of a yellowish or an off-white color, but you see that parallelogram is a basic shape that we will kind of use to represent where a plane might be. Well, a way that we could rename line QT, the simplest way would simply be to reverse the letters. We could say line QT, or I'm sorry, line TQ. Now again, I can name a line with any 2 points that are on the line itself. So I could also say NQ, because point N is on that line. And I could very easily turn it around. I know I'm giving you more than 2 here, but we can say that is line QN. So there's 3 ways that we could do it so far, and I could also simply call it line M because of the italicized M that's right there next to the line. Now, I want to point out one thing that I would like you to make sure that you do not do. As a teacher with lots of experience, I see students do this, even though I do my best to try and point out not to do this. Whenever we name a line, you only use 2 points on the line. And what I often see students try to do is they'll name the line something like TQN, where they use 3 points. Okay? Lines cannot be named with 3 points. They can only be named with 2 points. So don't name a line with 3 points. So let's go back to the blue here. All right. How can we name plane P? Well, plane P is named because of the large capital letter off in that corner of the parallelogram. But again, based on the characteristics of what a plane is, as long as I have any 3 points that are not on the same line, I can name the plane. So for instance, I could name it plane, let's say RSV. And I could name it with, put those 3 letters in any order that I wanted to. I could call it plane VSR. I could call it plane SRV, and so on. As long as I use those 3 letters in any order, because they're not on the same line, it works. Well, is there another way of naming it? Sure there is. I can call it plane, and if you notice, there's 4 points that are on the plane itself that have been identified for us. So I could call it plane VRQ. All 3 of those points are also on the plane that's been identified for us, so we can use those 3 points because they're not on a straight line. So those are 2 ways that we could name the plane. All right. Now, here is a little bit of vocabulary term that you may need to know. We have 2 terms here. I have collinear and I have coplanar. All right, well, what do those mean? Well, if people work together, they're called co-workers. So collinear, this means that I have things that are on the same line. And coplanar, again, the prefix of co means that I have something together, means that I have things that are on the same plane. So there's a couple of vocabulary terms that we want to make sure that we understand what they are. So the first question says, what are the names of 3 collinear points? Meaning we want 3 points that are on the same line. Well, I could use points R, points Q, and point S, because all of those are on the line that's kind of going diagonally sideways. We could also call that line L if we wanted to, but we're identifying collinear points, so let's stick with R, Q, and S. And some of you are recognizing by now, well, hey, there's another set of collinear points that I could use, or we could, instead of saying RQS, we could also use T, Q, and N. All 3 of those are on the same line also. So what are the names of 4 coplanar points? Well, this one we're going to limit to just what we see right now, and I can say, well, I have points R, Q, S, and V. Those 4 points are on the same plane. Now, a lot of times what I like to do in a classroom is I would say, well, students represent points, and because we're all standing on the floor, the plane would represent a floor, and students, because we're all on the floor, are all coplanar to each other. Now, I could also say non-collinear, which means I am not on the same line, or I could say non-coplanar, which means I'm not on the same plane. So talking about the students on the floor, if I decided to stand up on my desk for some reason, I'm no longer on the floor, I'm above it. So I would be not on the same plane, therefore I would be considered non-collinear. Okay. Now here's where things are going to start to get interesting. How many planes are in the figure? What I want you to do at this point is go ahead and pause the video and think about it. How many planes are in the figure? Because the answer that most people are going to go with is not the correct answer. All right, and I want you to try and think about it for a second. So pause the video and try and figure out how many planes do you see. Okay, now that we're back, what I want to look at, obviously plane P is there, right? That's the easy one to see. And this is the first example that I really want you guys to understand. Something exists whether it's explicitly drawn for us or not, based on its characteristics. The characteristics of a plane is that a plane always exists anywhere I have 3 points that are not on the same line. So instead of simply saying plane P, I could also say, let's say plane. Now I can't say plane RQS because those 3 points are on the same line. And I can't say plane RVS because also those 3 points are on the same plane as P, so it's just another way of naming the same thing. But let's see if we can identify any other points that are not on the same plane. Well, here's point V, here's point S, here's point T. Okay, now if we connect the dots, it looks like a triangle. But the idea of a plane is that it extends indefinitely in two directions. And so it really kind of keeps going out and out and out. So because those 3 points are not on the same line, they do create a plane, even though it's not expressly expressly drawn for us. So here I can name a plane VST. Okay. So now that you're identifying that, hey, there's more planes here than stuff that's been expressly drawn for us, let's see if we can identify any more. All right, well, let's keep using point V as our starting point, and let's see what we have. Now, could I say plane RNS? Well, plane RNS and plane VST that we just identified, those would actually be the same plane because we're using point V and S from the last example, and because point N is on the same line as point T, plane V and S unfortunately isn't going to work for us. So let's go ahead and scratch that idea. Well, is there any others that we could see? Well, what about TV and N? Does that one work? How many different planes that we can identify? And I want you to see how many you come up with. And again, at this point, I want you to make sure you write them down in your notes. And this would be an excellent point of conversation in the comment section of our classroom. So think it through and see what you come up with. So one minor change that I made to your notes is I didn't realize this, but this I wanted to change, JMP. We don't want to make that one. So this is just building on what we were just talking about. Here I have 3 rectangular prisms, and I don't really know why point K and Q seem to be at the same place, but anyway, let's go ahead and take a look at these. Shade in the planes JKQ, PQM, and NRL. All right, so let's look at JKQ in the rectangular prism on the left side. So J, K, and Q. Oh, that's why K. It just looks like K and Q are so close to each other. But here we can see if, again, we connected the dots, we would have 3 points that are not on the same line. So according to the idea, the characteristics of a plane, if I have 3 points that aren't on the same line, then they must create a plane. So the plane that would kind of exist inside of this prism would be a diagonal flat surface that goes between lines JK and lines RQ. So just because it's not drawn for us in the prism doesn't mean a plane doesn't exist there. We have to understand what are the characteristics of a plane so that way we can be able to identify them properly, whether they're given expressly drawn for it or not. So now let's look at PQM. Here's P, here's Q, and here's M. All right. So again, if we connect the dots, we can see we have 3 points that are not on the same line. So inside of the prism that we have, to be contained inside of it, we would see a diagonal plane going from the top left to the bottom right. And finally, in RL, we'll have a point here, a point here, and a point here. And again, those 3 points are not on the same line. That one is a little harder to see. It almost looks like a straight line on the board. But again, those are 3 points that are not on the same line. So they're going to create a flat surface inside of the prism going diagonally up from left to right. So those are 3 planes that we can see inside of a prism, or inside this particular prism, that even though they weren't expressly drawn for us, they do follow the characteristics of any 3 points making a plane. So there we go. Now at this point, some of you may have questions. If there's any questions about how we're doing this or you don't understand something that I explained, please make sure you write them down and address them to me either in the comments of the classroom or email them to me, and I'll be happy to answer them as best I can. Now, the last thing that we're going to talk about in this video are postulates. So here, I mentioned at the start of the lesson that Euclid formed everything that we know about geometry based on 5 postulates. And remember, a postulate is a statement I can accept to be true. You don't have to explain why it's true. So there are the 5 postulates, and I gave a picture kind of what each one represents. So any 2 points, there's a line between them. A line is infinitely long. There's a very good definition of a circle. A lot of people actually have a real hard time defining what a circle is. The only postulate that mathematicians have really debated over the years is that 5th one. They call that the parallel postulate. Because it's rather wordy, it's rather lengthy, a lot of people were like, well, is it really a postulate? So for the sake of our class, we'll just accept, yes, it is a postulate. But this is what Euclid did. And what I want you guys to do here is I want you to write your own example of a postulate. What is a statement that you can make that people can accept to be true? It doesn't have to be math related. It can be anything. I just want you to be able to show me that you understand what a postulate is. And this is what I'm going to be looking at particularly. I want you to send me your postulate either in an email or as an attachment to, I don't know, whatever however you're working at this at your campuses. This is still kind of new, so we'll be figuring things out as we go, but I definitely want a postulate from each of you so that I can understand that you know what a postulate is. So we'll be continuing the rest of the notes here in another sorry, I was just looking at the time. We'll be continuing this in another video, and until then, guys, thanks for watching. I hope you're getting something out of it, and any questions that you might have about anything, just email them to me or leave them for me in the comment section of the class. Thanks for watching, guys. Talk to you soon.